need to be at page 254. Are we good?
Yeah.
It just magically turned purple. Okay. So here is this picture that we just looked at. When we have a right triangle with, what do we call this segment right here? Yes, when we have a right triangle with an altitude drawn from the right angle, then we have three triangles that are all similar, okay? We just looked at that in that intro activity, okay? We are gonna come back to this. I need to teach you the concept of a geometric mean, okay? Arithmetic mean is when we have 5 numbers, we add them together, divide by 5, okay? But a geometric mean would be X when we have this proportion right here. A over X equals X over A. X is the geometric mean. Notice how we have a proportion with 3 numbers and the geometric mean is in there twice, diagonal from each other in the proportion. Okay. So like if I ask you to find the geometric mean of the numbers 4 and 9. Okay. Then what I'm asking you to do is I'm asking you to find the geometric mean. We're going to call it X. So I'm going to put them diagonal from each other in a proportion, and then 4 and 9 go in the other place. So that when we cross multiply the geometric mean that we are finding, it's multiplied together. So when we cross multiply, we get X squared equals 36. Which means X equals 6.
Okay, so the geometric mean shows up twice. And before right here, cross multiply. And then X times X equals X squared. That's 436. What's the square root of
So
36?
Harvey. So yeah, we have to square root both sides to get our X. I think that's the part. Okay, so can you just set up the proportion to find the geometric mean between 3 and 15? Could you do that for me, please? In spirit today over here? What your favorite team day? If you don't want one of your dance jerseys.
I'm having you and I'm having old LA Dodgers.
Okay, Brayden, what'd you set up?
X over 3 equals 15 over X.
Okay, so when we cross multiply, we get X squared equals 45? Question mark? Okay, when we square root both sides, is there a perfect square that divides into 45? 9 times 5. So our geometric mean is 3 square root 5. Okay, you can assume throughout this whole first half of the chapter that I want your answers to be exact. Okay, simplified radicals is what I need here, people. Okay. So now, let's go back to this picture right here. Okay, so we're on the next page. Okay. When we set up our proportions, right, we have this exact one right here. One of our proportions was AD over CD equals CD over BD. That was one of our proportions. Okay. So here is CD right here. What we just talked about with geometric means, what can you tell me about this proportion? Which one? Okay, so CD is our geometric mean, and we are going to use AD and BD with it. Okay, so if we have our right triangle with the altitude drawn from the right angle, we know we have three similar triangles, but what's going to happen every time is that the altitude is going to be the geometric mean between the two segments of the hypotenuse. So I like to kind of look at it like kind of like a tripod, right? Here are the three pieces of the tripod. That altitude is the geometric mean between the two pieces of the hypotenuse. So what we're going to do here, I want you to draw this picture for me, okay? That's not a good picture, Miss Woman. This is the picture I want you to draw.
Will it always be 360?
There is no 30, like I don't know if this is 30, 60, 90. There's nothing for us to know what the angles are right now. Notice how I said it right now, because we will be able to later. But we don't know if this is 30 or 60, 90, so we can't assume. Okay. The only time you can use your 30, 60, 90 rules is if you have a right triangle and one of those angles is labeled 30 or 60. Okay. All right. So if we have this picture, we know the altitude is the geometric mean with the two pieces of the hypotenuse. So do you notice how that's what's going on here? Okay. So I kind of like to do this. Okay, here I have them. Or maybe it would be helpful for you to like something like that. Like that. I don't know. I don't know if it help you. Okay, but that altitude is the geometric mean. So it goes in twice. And then 10 and 2 go in the other places. Now, in this problem, we are looking for the geometric mean. I'm not always going to ask you for the geometric mean. I might ask you for this chunk or this chunk. Yes. As long as the geometric mean is diagonal from each other, it doesn't matter the others. Because no matter what, Harvey, when we cross multiply, we'll get x squared equals 20. Okay. What'd you say? Yeah. When we square root both sides, we get x equals what? 2 square root 5. Thank you, Nora. I think that was Nora. Okay, is this the same type of picture?
Yeah.
Yeah, it's just oriented a little bit different, right? Okay. So you're drawing it. We have our 3 similar right triangles, but instead of breaking them apart and writing everything, okay, we know if we have the 3 similar right triangles drawn together like this, then we know that this guy right here is the geometric mean between these 2. Okay, so let's talk about how we're going to set this one up. Which one's the geometric mean? So 4 goes in twice, and then X and 3 go in. So we're not going to have an X squared. We're going to have a 4 squared. What? How about 3x equals 16? So X equals 16 thirds, and that's how I'd want you to leave your answer.
Wait, 16 sounds squared.
What?
Well, like we did like X squared. Well, it's because we are
Right.
because we're like
So when we cross multiply here, we're taking 4 times 4
Yeah.
and X times 3. So we are not getting an X squared. Do you see what I'm saying there?
we do the
Alex?
radicals of
Is
the
there-
square.
Correct.
Is there any time during this unit that you're going to expect us to use a decimal?
But now is not the time.
Why do you have to use decimals?
Better get used to it. Okay, now. There were 2 other proportions where we had the same thing diagonal from each other. Okay, so in this picture, okay. Why didn't I write it down? Okay. AC is the geometric mean between AD and, wait for it, AB. Or we can do it on the other side where,
Is it always the base that we use?
what do you mean by base?
Like the last 2 times we've been looking at the triangle, it's been like AD,
So I'm not sure I understand your question. Well, I just,
we're using the CA, the ABC. And we've always been using the base.
so like in this case, the leg is the geometric mean between this piece of the big hypotenuse and the entire hypotenuse, okay? Same thing over here, it's just the same thing, just reflected. This leg is the geometric mean between this piece of the hypotenuse and the entire hypotenuse. Do you see that? So like this guy goes with piece and whole. This guy goes with piece and whole. Okay. Okay, we're gonna draw a picture. You ready? Brayden is always ready.
Stop.
What are you doing? You, yes.
Who's that this thing? I got it. This is girl. We technically use the final two.
Yeah, that's gonna be more work.
We don't have enough information to do it.
It's 9 and 12. Why not be 3?
Oh, true. Yes, fine. Okay, now. These are connected, okay? This guy is the geometric mean between this guy and this guy. So we can set up a proportion where X goes in twice. And then 9 is the piece and 12 is the whole hypotenuse. So when we cross multiply, ooh, I hate using gray and red together if it's not this number. X squared equals 108.
X equals 49. Yeah, 49. No.
49 times what?
Yeah, 2. Yeah. No. Yeah.
It's 9.
Yeah, because
it can be
yeah,
9 on the 12.
Did you
And you can run 12, yeah.
So what about 36?
49 gets the one. Yeah, 49 is 3.
36 times what?
3.
I 3. I didn't work with the people. 4
So,
I didn't realize that.
6 started.
Okay.
Yeah. That's the worst part. I don't even know.
Yeah.
The worst.
Yeah, I just use the whole camera.
It's okay. There's no shame. Okay, this is what I want you to do. I want you to go to page 256. I don't want you to solve any of them. I just want you to set up the geometric mean proportions for these 4 problems. Don't solve them, just set them up, please.
Where's the homework? Would that be the mean? Is that another?
Well, everything's like facing to you without turning your finger.
49 and 49 or something.
8 times me.
I don't know.
Okay,
49 is the geometric mean between.
Oh, yes. At least multiple.
Okay, so either they're gonna give you the altitude with pieces of the hypotenuse, or they're giving you a side with a piece and the whole hypotenuse. So there's like two scenarios and you've got to decide which one you have information for. So either we're setting up the geometric mean of the altitude between the two hypotenuse pieces, or we're setting up the geometric mean is the leg of the piece and the whole hypotenuse. So there's two different scenarios. Okay. And what is the proportion in number 5 that you wrote?
X over 16.
Okay, if you have that inverted, that's okay too. Okay, if you have 16 over x equals x over 9, means the same thing. Okay, but x needs to be in the proportion twice diagonal from each other. Okay, we have the altitude is the geometric mean between the two hypotenuse pieces. Okay, how about here? Hardy, what do you have for this proportion? Okay, good. So y is the geometric mean between the piece of the hypotenuse and the whole hypotenuse. So we had to figure out what that was by adding 9 and 2. Okay. Ben, what do you have for number 7?
Number 7.
Mm-hmm.
T over 49, and then 49 over 7.
Okay, so 49 is one of the legs of the big triangle. It's the geometric mean between the little piece of the hypotenuse and the whole hypotenuse. Okay, so this goes with this guy and that guy. Okay, and then Nora, what do you have for 8? Good. 6 is the geometric mean between those two pieces. Now, if we were to solve the proportion in number 8, when we cross multiply, what would we get here? 36. What would we get here? 3 plus 12. Okay. Make sure that 3 gets distributed to both terms. Okay. All right. Your homework for tonight